Okay, here's some more examples from 1.6. So here they want us to solve the given equations. And here we're working again with addition and subtraction to solve equations. So what we have on our first one is we have x plus 6 equals 19. So that means our variable is x and we need to solve for it. So that means we need to get rid of everything else on that side. So to get rid of a positive 6, we're going to subtract 6. And what we do on one side, we do on the other side to make an equivalent equation. And so when those cancel, we get x on the left. And here we subtract 9 minus 6 is 3, 1 minus 0 is 1, and we get x equals 13. Now, we do our check to make sure, does 13 plus 6 equal 19? Well, 13 plus 6 is 19, so that checks. All right, what about this one? Well, here now we have 14 plus x equals 17. And again, the same thing applies. We want to solve for the variable, which is the letter usually. And so we will need to solve for that. So we need to get rid of this 14. So how do we do that? Well, let's subtract 14. And what we do on one side, we have to do on the other side. So those cancel. And if we want, we can even cancel them out like that. We get x equals. Now 7 minus 4 is 3. 1 minus 1 is 0. So we just get x equals 3 for that one. Now again, our check, does 14 plus 3 equal 17? Well, 14 plus 3 is 17, so that one does check as well. All right, so the next one, again, we're still solving for x in all of them. They just left x's in most of the problems. We could use a or b or y or z, it doesn't matter, a variable. And so here we have x minus 15 is equal to 13, and we need to get x by itself, so we need to get rid of that negative 15, so we need to add the opposite. So we'll add 15 to both sides. So when we do that, that cancels. 13 plus 15, so 3 plus 5 is 8, 1 plus 1 is 2, and that still equals x. Okay, so that's what we say our solution is. Now if we do our check, does 13 equal 28 minus 15? Well, 28 minus 15, 8 minus 5 is 3, 2 minus 1 is 1, so 13 equals 13. Check, we got it. Again, the checks are very important to make sure you do the math correctly here, as well as when you're doing the original solving the problem, because if you do an addition wrong here and then you do a subtraction wrong here, it might look like you have the right answer, but it could be wrong. And I've seen that before. People say, oh yeah, 8 minus 5 is 4 because they need it to be a 4 over here. And it doesn't work that way. You actually have to do the proper adding and subtracting on both sides to make it actually work. All right, so here we're solving for x again, and so we need to get rid of that 11. So let's add 11 to both sides. So those are gone. We have x equals, now we have 8 plus 1 is 9, 1 plus 1 is 2. So our solution looks to be 29. So let's do our check. And so does 29 minus 11 equal 18? Well, again, if we need to line it up, we can do that. 9 minus 1 is 8, 2 minus 1 is 1, and so 18 equals 18. That checks, and so that is the solution to this problem. All right, so now we've got an application or a word problem. So this one says 19 less than a certain number is 1. Find the number. All right, so looking at that, 19 less than a certain number. Well, a certain number, that's what we're looking for. It says find the number. So that certain number we don't know. So let's be different this time. Let's call that z, okay? And remember, is equals to, less than, that's going to be subtraction, but it's less than that number. So it says 19 less than that certain number. So 19 less than z, so z minus 19 is 1. Okay. So now we have a problem like we just solved right before here. You know, we had some number minus another number equals another number, and we had to add to both sides. So that's what we're going to do here too. We're going to add 19 to both sides. So those cancel. We get z equals, I'm writing equals in the middle here. Z equals 1 plus 19, that's 20. And so that is going to be our solution. And so now does that make sense? Does 20 less 19 equal 1? Well, 20 minus 19 is 1, so it checks. And so we say the unknown number is 20. And that would be then our solution, okay? Again, nothing hard. You just have to take time to read, see what they want. Usually the question tells you the variable you're going to look at. Find the number. That must be the number I'm looking for. That's going to be my variable. Again, any variable will work. Sometimes they tell you in the problem, use variable X or Y or Z. But if they don't, you can use whatever you feel like. All right, so here it says Mercy withdraws $430 from her bank account. As a result, the new account balance is $1,200. Find the account balance before the withdrawal. All right, well, that last sentence again tells us what our question is and what we're looking for. Account balance is what we're looking for. So let's call that again, maybe call it B this time for balance, okay? And it's before the withdrawal. So that's going to be, B is going to be our balance before withdrawal. And now she withdraws $430. So we subtract off 430. And as a result, the new balance over here, it says it is $1,200. So it is $1,200. Now we just have to solve that equation. Okay, so if we do that, let's add $430 to both sides. So it's gone here. So we get B is equal to, well, now we have 0. 3 plus that's 3. 4 plus 2, 6. 1 plus that is 1. So it looks like the balance before she withdrew it was 1630. Well, let's check and see. Does 1630 minus the withdrawal amount equal the 1200? Well, now I'm going to put that down below. So 430. So 0 minus 0, 3 minus 3, 6 minus 4, 1 minus nothing. So $1,200 does equal 1,200. So that does appear to be the correct value. So the account balance before withdrawal is 1630. And again, remember your units. This time the units was dollars, and so then that would be your final answer. All right, so this one says, example, tribal lands. The Yurok tribe has the option to purchase 47,000 acres in order to increase its ancestral territory. The first phase will include 22,500 acres in the Capel and Peckman watersheds. The second phase plans for acreage in the Blue Creek area. How many acres would be purchased in the second phase? All right, so how many acres would be purchased in the second phase? So that's going to be our variable. So maybe let's call it A this time, okay? So A is for acres. And what does it say? We have the option to purchase a total of 47,000 acres. And it says the first phase includes 22,500, and A is going to be how much is going to be included in the second phase. So we're going to take the 22,500 plus the A, and that should equal, it looks like, the 47,000. So it looks like we're going to take the first phase, 22,500, plus what's in the second phase, which we don't know, so that's our variable, and that's going to be equal to our total acreage that they're going to purchase, okay? So again, we have a simple equation to solve. So what we have to do is subtract 22,500 from both sides. And again, that cancels, so we get A equals. Now we have 0 minus 0 is 0, 0 minus 0 is 0. Now we have to borrow. That's going to become a 6. This is 10, so 10 minus 5 is 5. 6 minus 2 is 4. 4 minus 2 is 2. So, and that's acres, so it's 24,500 acres, okay? So the second phase will be 24,500 acres. Okay, so that's what we're saying is going to be our answer. And how do we check it? Well, we plug in that value for A, so we have 22,500 plus 24,500, and that had better be 47,000. Well, again, I'm going to line them up top to bottom so I don't mess up. So I'm just bringing that here. So 0 and 0, 0, 0, 0. 5 and 5 is 10. So that's a 0 here. Carry 1, 4, 5, 6, 7. 2 plus 2 is 4. 47,000 equals 47,000. So our check works. So the second phase will be 24,500 acres that they have to purchase. All right, so that's all the extra examples I have for this section.